All right, now in this amazing video, we are going to learn how to create an angle bisector. So we're going to have to do this with a compass. So I'm going to place the compass point at the end point. Sorry, I'm going to have to put the compass point at the vertex of my angle. So I have the metal point at the vertex of the angle, and that looks reasonably the vertex. And then what I'm going to do is I'm actually going to bring the compass setting a little bit closer because I don't want to have to stretch my compass later past where it can go. And then I am going to draw an arc. I'll use a different color here. I'm going to draw an arc that, it's still green, that intersects both legs of my angle. So then I'm going to take my compass, I'm going to place the metal point at the intersection of the arc that I just drew and the leg. And I'm going to extend this, all right, so that it is the exact distance between the 2 points of intersection of my arc and my leg. And then I'm going to make an arc I'm going to make my arc a little bit larger here. And then without changing the compass setting, I'm going to place the compass point at the intersection right there, and then I'm going to go ahead and now incidentally, as luck would have it, I am just now remembering that I didn't actually have to measure this distance here. Any distance that would have been past where I would imagine the angle bisector to be will work, and I can prove that to you by doing the same thing here. And then we are going to take our straight edge and connect the point of intersection with the vertex and draw our perpendicular bisector. Now I'm going to have to zoom in if I'm going to make it right, so I'm going to do that.
That was great.
So the problem with doing this on the computer is it will snap the ruler. You see how the ruler jumps around a little bit? The ruler will snap to the nearest pixel, which means I'm not going to get an exact line. I can't place it exactly where I want to place it, but even still, that is pretty darn good. And then just to prove that this is in fact an angle bisector, I am going to move this protractor over here, and here we go. All right, so this angle here, I'm using the lower numbers, is 70 degrees. Doing the same thing here. It is, mine is a little bit off. I don't know what else to say. There we go. 70 degrees. So we have cut this angle into two equal angles. We have created an angle bisector. All right.
Okay, I might mess it up, but...
Hold on, stop. Since I didn't use it, you gotta hit that. Oh. You want it there. The mouse. Yeah, and then hit the triangle again. There you go. And talk loud, please.
Okay, so I did 2 minus 4 over 2, comma, let's see, 8 plus 6 over 2, and that is negative 2 over 2, comma, 14 over 2. So then the coordinate I got was negative 1, comma 7.
All right, guys, do you have any questions with that?
Nope. No.
Nope. Okay. Just one little quick note. So finding the midpoint is you're essentially finding the average of the x's and the averages of the y's. And so 2 plus negative 4 is the same as saying 2 minus 4. That's the only little tidbit I want to throw in there. All right. So who's doing the length?
I am.
All right. All right.
Oh yeah, Wally.
Okay, let's go, Walter.
All right. So the first thing I did was make an equation. So I did negative 4 minus 2, and that term squared, plus the term 6 minus 8 squared, and then that whole thing is square rooted.
Now this is also known as the...
Distance formula.
There you go. Okay.
Go crazy, Wally.
So hold on a second. Avery and Claire, do you agree that we have properly plugged everything into the distance formula?
Yes.
Okay, go on.
And then I simplified that, so I got negative 6 squared plus negative 2 squared,
Okay.
and then that's square rooted. I forgot to say that. And then I simplified again, and I got the square root of 36 plus 4, which is the square root of 40, which is 2 times the square root of 10 in simplest radical.
All right. Yes, no, maybe so.
That's, yeah.
Yeah.
Yes. Okay.
Oh yeah.
Oh yeah. All right.
Crazy, Wally.
Okay.
Is that-
Avery, you're up.
Oh, let's go. Okay, this is probably not the fancy way to do it, but it's okay. Okay, so what I did is, well, you can draw it out, but you can also just take the coordinates and find the rise over run.
Find the rise over run. Okay.
So I did 2 minus negative 4, which is basically 2 plus 4.
Okay.
Yeah. So that was the run, and that equals 6. And then the rise is, and then the rise is 8, and the rise is 8 minus.
I think you said 8 minus 6, which is 2. Okay.
That's equal to 2.
And what goes into 2 and 6? 2.
Yeah, 2, not 3.
I would say equal to
So we get an answer of 1/3.
equal to your slope.
All right. So, all right. So